Hi Kayla. Now I totally get what you're having an issue with, and you notice what I did here. I have the page you sent me and the beginning page from your notes that you sent me as well. Also, you'll notice that the things on the right hand side, your trig identities, you really have to know those. There's no way around it, kind of thing. And if you know those sort of off by heart, then it becomes more of a game than anything else. And you're not actually trying to make the left side equal the right side. What you're trying to do is make both sides the same. So there's basically no really rule on how to do it. It's just knowing the identities and making them work for you. So let's have a look at number 2, for example. Now you got the head circle here. Let's look at 2a. Okay. So 2a says that we have cosine plus cosine x, so cos x plus cos x tan squared x. And I'll show you how this comes together in a second. Equals secant, oops, my bad. Tan squared x equals secant x. Now when you first look at that, you're like, oh my god, I have a headache already. But you look more closely at it, the first thing I see when I look at this, I see cos here, and I see cos here. So, and also I notice that it gives you a little hint in the question because it says use factoring. So, when I see 2 cos here and it says use factoring, well, let's factor them, see what happens. So then what I do, if I were to factor cosine out of this piece right here, just show you, factor out of this piece right here, then I want to have cosine x, oops, my bad, getting ahead of myself, cosine x outside of 1 plus tan squared x equals secant. Oops. What is going on tonight? Secant x. And here's where it comes back to the point where you need to know your identities, because if you know your identities, that's half the battle, because then you suddenly realize that 1 plus tan x, tan squared x is right here. 1 plus tan x squared, sorry, tan squared is equal to secant squared x. Now you can sort of start seeing things fall in place. So let's replace 1 plus tan x squared with secant squared. So now it becomes this right here. It becomes cosine x times secant squared x equals secant x. And you're still thinking like, oh, I don't get it still, because it's like not making any sense. Until you look back for a second and think, what is secant mean? What does it mean? Well, it says here that secant is 1 over cosine. Okay, well, let's have a look at that. Okay, so now we have 1 over cosine. So looking back here, I'm going to have, this is, sorry, my phone. So secant squared here will be 1 over cosine x. On the other side here, we're going to have cosine x times 1 over cosine squared x. So if we keep looking closely at this, notice what happens is that we have cosine x here and cosine squared x here, and we're left with 1 over cosine x equal to 1 over cosine x, and you just prove that they're equal. So you see what we did here, we noticed that we didn't actually solve one side, we didn't actually solve one side to make it look the other side. My way of doing it basically is just showing that both sides are the same. After all you're trying to do is prove that they're equal. When you get down here, you see that both sides are in fact the same, so they're equal. So there's no solving one or the other. It's just taking what you know, more or less. I think of it as playing with identities, or manipulating the identities, or having fun with identities, making them turn into what you want them to turn into. So in any case, that's one. Let's have a look at another question that you had here. Let's go back up. Okay, 2b looks crazy. Sine squared x. Let's go sine squared. I'll write this down as a hard part. Maybe I'll do this. It's easier. And I'm going to bring the page here over as well. It's not bad. Just so I show you how the identities work. So when I first look at this, when I see the sine squared x minus cosine squared x, okay, that really jumps out at me, because when I see that, it reminds me of this right here. I use a different color right here. As you mentioned how important that was in the last video, that's what I see. Except for this one says sine squared plus cosine squared. So, but it's something to think about. So let's go back here and see what else we know. How about that's going in place? So what about if we took this one here and just get rid of the fraction? Okay, so basically, let's multiply both sides. I'll show you now. One second. I'm just going to make this. It's going to get large. So I better move it down. So if I want to get rid of that fraction piece there, I'll multiply both sides by sine x plus cosine x. Okay, so if I do that here, and again, all I'm trying to do is make this side here look the same as this side here, and that's my goal. So if I do this here, let's see what happens here. And let's multiply both sides by sine x plus cosine x. And I never really worked this out previously. I'm just doing it on the fly, because you should see how the thinking process works. And if it comes along that I'm working through this and it doesn't seem to work right, you just change your process to make it work right. So that's multiplied by sine squared x minus cosine squared x all over sine x plus cosine. And I'm going to need more space. Hang on a second. Put this over here a little bit. And then, you know what I do? If I do something to one side and I multiply it to the other side, it's still equal. So on the other side, I'm going to have sine. Oops. Sine x minus cosine x multiplied by, sorry, I have to do a little down below here. I'm running out of room. So it's going to be multiplied by sine x plus cosine x So on the left hand side, you'll see what happens is that if I multiply by this piece here over this piece here, these cancel out, they're gone. What am I left with on the left hand side? I am left with sine squared x minus cosine squared x equal to, I want to just write this up in one line so you can see it better. So it's going to be sine minus cosine x, okay, sine x minus cosine x. And what I'm going to do, I'm going to put this in brackets just so you see it a little bit easier. So it's going to be sine x plus cosine x. Now, the reason why I did that is because now multiplying these things here, I'm not sure if you've ever seen this before, I'm pretty sure you have, but what's going to happen is we're going to do the FOIL. FOIL meaning first outside, inside, fast. So doing this on this side over here, we have sine x multiplied by sine x is going to give us sine squared x. The outside is going to be sine x multiplied by cos x is going to be, so it's going to be plus sine x minus, or sorry, plus, not bad, sine x cos x is multiply sine x cos x. Again, I want to need more space. I need a bigger board, I need a bigger computer. Not going to happen. So in any case, doing that, then the inside is going to be minus cosine x times sine x. So it's going to look like this. Minus, minus sine x cos x. I'm going to move that over further again because I want to see this piece right here. This is an important piece. And the last part is going to be minus cosine, minus cosine x times cos x, which is going to give me minus, minus cos squared x. And that all equals, on the other side, sine squared x minus cos squared x. And I'm just playing around with these things because I know how to factor, I know how to conjugate a denominator, I know how to get rid of a denominator in a fraction. I'm using all the skills that I have based on what I know from math at this point, because I'm not doing anything special here. I'm just getting rid of the denominator up here, just getting rid of this piece, multiplying by both sides. You know, it's basically the same as always. Over here, I'm apply that side, I just foil it. You know how to foil it because that's way back in the early days. And so it works out to be exactly the same thing. Except you notice one thing here. I'm going to highlight this piece again exactly because you see that we have plus sine cos x minus sine cos x. They're going to go away once I subtract them. And what am I left with? On the left hand side I have sine squared x minus cosine squared x. On the right hand side I'm left with sine squared x minus cosine squared x. So now you can see that like they're both the same. I'm done. It's true that the identity works, it's true, they're both equal, and that's all you gotta do. Just make both of them look the same on both sides. There's no really, I don't really have a skill, I guess, or a procedure or a method for doing this. What I really do use is back up here a little bit. I'll show you. Oops. You need to know this stuff here. This. You need to know that off the top of your head. So you recognize that, for example, secant is 1 over cos. You recognize that tan, for example, is sine over cosine. These things are just connections you need to be able to make. In order to make these things easy, if you know this part right here, they will come a lot easier to you. Again, once you get down here, it's just looking for things basically to expand it, to make it simpler, to collapse it, whatever. So just whatever jumps out at you, that's your starting point. There's no, it's like kind of factoring. Give me an example here. We'll scroll down. It's kind of like this. If I were to factor (16/20), I can go. That's going to be the same as 8/10 or 4/5. That's fine. But if I would divide top and bottom by 4, it's going to be 16/20, and right away I see it's going to be 4/5. Both of them are the same answer. I arrived at them two different. Doesn't matter. So anyway, the point is that yeah, attack these the best way you know how, and you can't underestimate knowing your identities off the top of your head, and it'll make this a lot easier. So hopefully this is helpful. Have any more questions? Again, don't hesitate to ask, and I'll make another video. It's awesome. This is fun for me, so don't feel like you're being a bother. You have a great night, and I hope this is very helpful.